All right, we are going to get going. Good afternoon, everyone. My name is Austin. I'm Inside Sales Specialist at KUKA Robotics. This webinar is the KUKA.RoboTeam Masterclass webinar. This will be hosted by Anton. He's one of our sales applications engineers, and I will now be passing the floor over to Anton for another intro.
Hi, good afternoon, everyone. I'm Anton Athanayake. I'm application engineer with KUKA Robotics. I like to talk to you about one of our tech option packages that is Robo Team version 3.1. Robo Team, we sell this as an additional option package for our controllers. You can get all the instructions you need from our expert, KUKA expert, and pricing packages from our KUKA marketplace. If you don't want to go to the marketplace, you can talk to your regional sales account manager and ask for a quote for you guys. So if you go click the expert, you will get to a web page like this that gives you additional information. All the information you need to understand what it is and how to operate, with all the way to examples, will be in this manual. And it is accessible for anyone. So it's even with a basic package where you can register and get an account at the expert website for free. So if you haven't done this, please go to expert.kuka.com and sign up to get all these details. The pricing is in the marketplace. So this option package is not cheap. It's 6,700 something. So you can buy this right off of this website or talk to your sales account manager for the region. Robo Team needs more than one robot. So if you have multiple robots, like 3 robots, you need 3 times this. This price is for each robot. System requirements. You can use this on a KRC5, this is our newest controller, or KRC4 that runs older version software 8.6. Both of these versions will accommodate the Robo Team 3.1. You also need a laptop to configure this. But other than this, there is no other hardware you need to purchase. If you are using KRC4s, all robots must be KRC4s. If you are using KRC5, it must be KRC5. You cannot mix KRC4s and 5s in this Robo Team. In the back of the robot, this is for KRC5s, you will have this 8 network ports. Normally these XF4 and XF3 is disabled. It's not used. But for this option, this will be enabled. So if you have multiple robots, all you need is a network cable. You connect from XF3 to the next robot, XF4. And from the next robot, robot 2, to whatever the other robot, you use this daisy chain. That is all the hardware you need. What is Robo Team? Robo Team has 2 sections. In this team, robots can do program cooperation or motion cooperation. Program synchronization is and manage workspaces and exchange data falls under program cooperation. Program synchronization is useful when you have multiple robots. They can start and stop routines or start certain parts of the motion at a certain time. And a robot master can call these routines if it needs to. Manage workspaces. Sometimes robots are too close to each other and they try to occupy the same space to do their work. When that happens, robot can crash. Managing spaces is important. So we can get the robots to cooperate with each other and ask and request to enter and exit out of these spaces so they can avoid crashing into each other. This is a logical operation, not a geometric operation. The next is exchange data. The data that is global to a controller can be shared with the other controllers. Motion cooperation. Most people use Robo Team for this. Motion cooperation can synchronize moves from one robot to another. Multiple robots can follow one robot or a positioner that's attached to a master robot. Geometric coupling. So this is important. A lot of robot companies use this for welding application, gluing, dispensing. One robot hold a part and the other robot follows and do welding or gluing at the same time. Load sharing is also can be used with this particular coupling. Shared workspaces. So in this example, R1 and R2 needs to pass through this white space. So when this happens, to avoid crashing into each other, R1 at P1 position can request to enter this space. And then if it gets the okay to go, it can just pass through this and exit the workspace at P3 when it's clear. Then R2 at P1 is also waiting if it needs to until the robot 1 moved out of the way. After it moves out of the way, it will get the okay to enter, and then R2 can enter the white space. Geometric coupling. So you have a master robot and a slave robot. So the slave robot is going to, for example, a slave robot, let's say, going to follow the tool on the master robot. For this, it needs to know where the master robot is, the rod root of that robot, where it is relative to each other, and the base offset from the root to the tool. In Robot Studio, we use LK underscore. This is for link, and it is something that Robo Team use. Robo Team lingo, I guess. Geometric coupling application, we can do these things. Lifting heavy loads like glass, 10 feet long, 5 feet wide, and 3 inches thick glass can be lifted by sharing the load. Two robots can lift it and move it. So for these things, normally you use the same size robot so they can share the workload easily. On the example on the right side, two robots are holding, could be I-beams or something heavy, right in place, and for the process robot to weld it or glue it. Geometric coupling can be used for this type of application, where the slave robot is welding the part that needs to stay relatively perpendicular to the part surface where it's welding. So the master robot could be holding the part and rotating it and making it easier for the slave robot to do the work. And on the example on the right side, master robot has a positioner attached to it. And the master robot can share the positioner information as a base to the slave robot so they can work together while the master robot spin the positioner. This is also good for welding and dispensing gluing applications. Do you guys have any questions so far?
There are not any questions yet.
If you have any questions, just raise your hand and let me know instead of waiting till the end.
Oh, there's one that just came in, Anton. It says, can shared workspaces be dynamically defined?
No, it cannot be dynamically defined. It needs to be defined during the design time in Work Visual and download it to the robots. We'll get to it. So I like to do a little simulation to do this thing. So I have Work Visual 6.0, and let's set up 2 robots to do this thing. So I also have KUKA.RoboTeam. Let's connect this to a new robot. Let's start a new project. Let's do a KRC5. Okay, here we go. Use the latest software. Ignore these right now. Here is our controller. Let's get a robot. Let's get a KRC16. KR16. R1610. -2 is the newest one. So let's get this, drag it, and put it on the controller. Get another controller. Has to be KRC5. Using the latest software. And for this, we'll use a different robot, different size robot. 1440. That's also a -2. And let's name these guys. First one, we'll call them, it's the master. Second one, slave. Go to the hardware view and add Robo Team. The Robo Team is in here. We'll drag the robot master into the team. And then drag slave into the team. It's here. Slaves here. And there is a pendant here. You can see it's connected. When you are doing this, it's important that you have all the I/O device net or Profinet or Ethernet IP I/O already mapped to your PLCs. I've done all the safety configurations and the programming. When you compile and download, it will take less time because the Robo Team, when you try to make changes and download it, it will download to all the controllers that is in the team. So that means they will get downloaded one at a time and get it rebooted, all of them, even if you make a change for one of them. So first thing is important to get all the robot programmed before you put them into a team. Then you add option package version 3.1. Add Robo Team 3.1. So we talked about adding workspaces. This is where we add workspaces at the design time. So like I said, it is logical, not geometric. So you can see here, this workspace is owned by the master, or you can say it owned by the slave. But that means the IO that is required to do this management owned by the master or the slave. So you have to select which one. So if the owner is the master, when the slave needs to go to that space, it will ask the master the question, can I go into this space? And here you can rename it if you like. Shared workspace. And that's pretty much it. Now the team is there. Then you have to decide how your application works. Who's going to follow who? So this is the master, and because you know there is a master, because there is like a small icon of a clock. So he's the synchronizing master as well. So if the slave needs to follow the master, you click the slave and drag this arrow to the master. And it says KR10 R1440 should follow KR16 R1610. We will make a couple of tools. This one, the slave, I will make a tool. Tool 1, detail. Let's put a tool 200 millimeters long in the Z direction. And this might be ready now. Okay. And I'll go to the accessories, get rid of the energy supply, put him on the center of the, and I'll rotate this guy. Okay. And then we will add another robot, which is the KR10 R1440. Put this guy onto the right side. While it's doing that, we'll make the master tool, tool 1, detail, Z direction, 300 millimeters tool. Okay. And let's go back to this guy, get rid of the energy supply, line this guy up. Let's put him 2 meters in the Y direction. So here are the 2 controllers, one for each of them. So they are ready. So this is pretty much it. We expect all the code to be there in the files. If you can see this, R1, right now there is nothing in there, but when you're actually doing this, all that stuff need to be there before you add them into the team. And let's look at this and get more info on this guy. So this is the KR16's base frame. So relative to KR16, KR10 is in the minus C direction, 2000 millimeters. it's minus. Because we saw this guy is in the minus C direction. KR16 is minus C direction for the KR10. After that, we are pretty much done. And then compile and download. So now you have two controllers. You find where you need to go. So since I have done this before, I have already connected this. So you select your master and then select your slave. I have two office PCs in Detroit that I'm connecting it to a couple of thousand miles away via internet. So there is a little lag in visualizing this through KUKA.RoboTeam. So don't worry about that. Then after you connect them, the IP addresses, you can say finish and compile and download. I'm not going to do the download because it takes some time to do the compiling and download and rebooting it. So we pretend we did this. After this, you are pretty much done here. So I will move this out of the way. And this is KUKA.RoboTeam. So in KUKA.RoboTeam, you go to RCS. Oh, no, here. Controller. I want this to be attached to this controller. View only and select the master. And I do the same for the smaller robot. This view only, attach, and here is the slave. Then it should work. But there are a few other things I did here. So I'm going to move this out and show you the one that I want to work with you guys. This is the same thing, except I have a big metal sheet that I want to move together with this robot. There's a pallet here, and each robot is holding a tool. That's the large one is holding a 300 millimeter tool, and the small one's holding a 200 millimeter tool. So we'll use this for our lab. I'll have this one. I will close this guy and move these. These are my Office PCs connected to the ones in Detroit. So they are live. They have already downloaded the code to these. That is the master. It says the master here. And here is the slave. So I have three screens to share. We'll figure out how to share these together. Okay. Now I run this thing. I was not expecting this, but this is what I got. I will see if I can make this work. It is correct. Okay, I'm going to have to reboot these guys. So let me do that. It's going to take a little time. That's okay, but I will explain other things while it's doing that. So here is the slave on my left side, and the master is on the right side. So let's talk about workspace monitoring. Let's open this up. And workspace monitoring for this guy. So what it does is it goes all PTP moves, nothing special, all going max speed. We don't want to sit there and wait for it to go slowly. And before this, I want to show you the tool and base assignments. Master has a tool, 300 millimeters long. Mass and all of that is not calibrated yet. Doesn't matter. It doesn't use any base frames, no external kinematic system. He's the master. The slave obviously will need all of that. So while here, let me open this guy up, Robo Team. Slave has a tool, 200 millimeters in the Z direction, have a base. This is the KR16, which is the master, and hits its tool. When you calibrate its tool, you can copy that information to this. And then the external kinematics, this is the base frame of the master, where it is relative to the robot, this current robot. And it is in the Y direction, minus 2000 millimeters. Okay, let's see if it works now. Seems like it's happy. So it's running. It's running. How do I know this? Because it's running right here. I will move this to the side, close this. And cancel, open it. So workspace monitoring. There are no workspace monitoring in both of these. So let's make them run. So I'm going to run the first one to the BOC. It is important that each robot needs to hit the BOC. You need this only for T1, T2, and auto. But when you're running in external, you don't care about it. So now they are at BOC. I am going to run this. Here's the master. I'm going to run this guy. So when you're running it without workspace monitoring, this is what will happen. They will both go to the same location. As you can see, it is going to crash. And it is crashing. Both of them are running, it's crashing. This is not what we want. We want to have a better way to do this thing. So each robot moves from the home location to the safe height. Right here, I'm going to say command Robo Team workspace. Enter workspace. So this is the one we added. I'm going to say enter request there. And after it goes in, down, up, back to safe height, it can say, hey, I am done with it. Exit space. Exit workspace. And we'll do the same for this guy. Enter workspace. Okay. Exit workspace after it goes to the safe height. Okay. Reset the program. Getting it to move to the first BOC. Okay. And reset the master. Move him into the BOC. After that, here are the two code. Then I'm going to run it. They are both running. Small one will get to, the slave will get to that space first, request it, get the OK going in. This master is stuck. He cannot get there. The slave is moving and it will exit the space. Then the master can go to the same area. Now the master get to go there. Basically, this is what workspace sharing is. You can have lots of workspace sharing, but they are only logical. If the part of the body of the robot or the part of the end effector is in a place the other robot will crash into, it will crash into it. So this is a logical operation. That please remember that it's important. Well, it is done. So slave is completed, finished this code, and now the master is completed. I'm going to close this program and then show you about this. Geo-sync. So let me make them move to a location and make this guy move to that location. Okay, I think he did not finish. Okay, now I'm gonna zoom it in. There. So you can see they are pretty close to each other. So I'm gonna keep it like this. Here is the slave. I'm gonna change its base frame to the LK base and keep the motors enabled. Then I'm going to move my master. See, the slave robot follows the master. They are linked geometrically. No, it stopped it because the slave couldn't get there. Again, it happened. So I need to go the other direction. Oop. Z direction, Y direction. So this is geo-linking. So you can have one robot move while the other robot, multiple robots, follow the master. Next one is a little interesting than this. So let me reset this, all of them. Reset, load sharing. Load sharing. So let me move them side by side. Load sharing is, here is the master. Starting from home, reset the output. This output is linked to the robot simulation. We use that to grip and ungrip part. So output is on means gripper on. Output one is on off is gripper off or release part. So it moves into the safe area and then it goes down to the part right here. And then since the small robot, the slave is smaller, it moves faster because it's closer to the its PCP. Then it waits until the other robot sync into that same position here, right here. So he goes there and waits. So if you look at this code, let me start this. Program syncing. This is where we use program syncing. So I can give a name, a specific name, unique name. Robot 1 and 2 wait. Both of them wait. Or you can say, if you get there, don't wait, do your thing. But for right now, I'm going to use it to wait. So at the same location, I'm using this guy, and I have to have the same text here, program sync, and wait for both of them to come there. After they both come there, they are in the pod, the gripper actuate, gripping the pod. Here's output 1 to be true, master output 1 true, and wait a half a second. After that, it's linking geometrically to the other robot. Master is setting, I am linked. So if you look at this code, here's the master. Link to is important. That's the same text I need to use on the other one. Is the slave, linking to, and then I have to specify the base frame I need to use. And this is the base frame of the master. After that, master is going to go up, move to the palette, go down, and says unlink. And from the slave side, there are no moves. It's just linked to the master. So it's just going to follow what the master is doing, keeping the same relative position from the master's TCP. After it do all of this, it's just going to unlink it at the same location. After that, output to say false, and then both of them go home. So let's see if this happens. I need the first BCO. Okay. Yes. Slave moved there. And now the master is moving home for the first BCO. Make this a little bit smaller so I can show both of these screens. And after that, we run. Both of them are moving. As you can see, the slave gets there a little quicker than the master. But because we have a program sync, the sync one, it's going to sit there and wait. Yes, he's going to sit there and wait. And now he's waiting. And this guy need to go there and wait. Both of them will pick it up, move the heavy object, place it down, ungrip it, and then they go home. When it was moving, you saw there was one robot, there is a lag to it. That's because of the update speed on the KUKA sync. It needs to go somewhere to get it updated. It updates one at a time. So you can see it's just a little choppy. It's not very smooth. So basically, this is Robo Team. It's kind of cool when you actually see it in real life. One thing I forgot to mention, you can have up to 6 controllers in one team. You cannot have more than that. I have not seen more than 2 at a time. Maybe if you would like to see some applications. If you have some, let me know. Any questions?
I think there was just one other one. Maybe you got it too. It was, how would the interconnection or wiring differ on a KRC4? I think that was when you were working on the simulation.
KRC4, I am not sure. Let me, please write down my contact and get back to me, or I will try to get back to you soon with the wiring diagram. but make sure that the KRC4 has the OS 8.6 installed. Any other
Alrighty,
questions?
thank you. That would be it for now. That was it. You answered the rest of them, so that will be it.
Thank you, guys.
So that's it.
Please write down my number and let me know if you have any questions later on.
Yep, and this webinar will also be available on our website at mykuka.com. It will also be available on our YouTube channel, it's under KUKA. And a follow-up email will be getting sent out with a link to the webinar as well in about a week or two. Thank you.
Okay, have a good day.
Industrial intelligence.